Bismillahirrahmanirrahim. Assalamu alaikum, dear student. Hopefully, you are well and doing well in this pandemic situation. Today, we discuss uh, the lecture number 6 in mathematical modeling. The topic is draining a tank. Modeling and solution of such kind of problem. How to model the how to model the phenomena of draining a tank. Okay. Before beginning to start your lecture, as usual, if you have any problem regarding this lecture, you can feel free to contact on our WhatsApp group or on Zoom ID that is mentioned below. So let's begin our topic. That is draining a tank. Draining a tank, basically in hydrodynamic, Torricelli's law states that the speed v of efflux of water through a sharp edge hole at the bottom of a tank filled to a depth h is the same as speed that a body, in this case a drop of water, would acquire in falling freely from a height h, that is 2gh and under root v. Okay, where g is the acceleration due to gravity. This last expression comes from equating the kinetic energy with the potential energy mgh. Look at this is half mv square and mgh. If we equating these both things, we get the value of v. Okay, v mean the the speed of a body which is dropped from the falling freely from a height h. And solving this one, we get v like 2gh and under root. Suppose a tank filled with water is allowed to drain through a hole under the influence of gravity. Suppose we have a water tank which is filled of water, and we have a hole in the bottom of the tank, and the water is fall from that hole due to the gravity. We would like to find the depth h of water remaining in the tank at time t. Okay, please concentrate on this sentence. We would like to find the depth h of water remaining in the tank at time t. It's mean we going to find out the height of the water in a tank with respect to time, and at time how many water, yeah, how what is the height of a water at time. So that will be that is our target, to find the height of the depth of, which is denoted by h, of water in a tank at time t. Consider the tank shown in figure 1. Look at this one is the tank. Okay, this is a tank which is filled from water, and this one is a hole which is at the bottom of the tank, and a water is falling out from the tank due to gravity. Okay, due to gravity, and we find the height. We need to find the height of the water at a time t. Okay, for this we construct a differential equation. This AW mean the area of water, and AH mean the area of a hole. Okay, so now look it. If the area of the hole AH in foot square, and the speed of water leaving the tank is v2gh, also in feet per second, then the volume of water leaving the tank per second is volume of water leaving the tank per second will be equal to ah into 2gh. Okay, as to v and multiply the area would be the volume of the water leaving the tank per second. Thus, if Vt denote the volume of water in the tank at time t, then the rate of change in volume with respect to time will be equal to minus ah under the root 2gh. तो ये आपके पास वॉल्यूम का जो रेट ऑफ चेंज है वो शो कर रहा है। लेकिन यहाँ पर नेगेटिव साइन वेयर द माइनस साइन इंडिकेट दैट वी इज डिक्रीजिंग, ओके, वॉल्यूम इज डिक्रीजिंग. If there is positive sign, so the volume will be increased. In what case the volume will be increased? If some water is input from the hole, okay. Note that that we are ignoring the possibility of fraction at the hole. It may cause the reduction of the rate of flow there, okay. In this case we neglect the fraction, the possibility of fraction at the hole. The fraction of water and the fraction between the water and the hole is neglected. If we have a question, we have a problem, that in that case we consider the fraction, so then we put some c, some constant in here. Sorry, just a minute. अगर हम फ्रैक्शन को इग्नोर करेंगे तो फिर तो यही सही है, लेकिन अगर फ्रैक्शन को आप इग्नोर नहीं करेंगे तो फिर ये ए एच के साथ सम कांस्टेंट होगा, लाइक सी, we put c या any other constant, and this c is denoted the rate of fraction, okay, yeah, the value of fraction between the water and the hole. Now if the tank is such that the volume of water in a time t can be written as the Vt is equal to area into height, okay. अगर आप इस टैंक की वॉल्यूम देखें तो वो आपके पास एरिया और हाइट के बराबर होता है. सो सॉरी, लाइक दिस वन, लाइक अगर आप इस केस में देखिए तो वॉल्यूम ऑफ this one will be equal to the area of this surface, which is AW, and height of the water. So that will be the volume, which is, you are already familiar with this formula volume, how to find volume, where AW is the constant area of the upper surface, where AW of the water, okay. Look at this is the constant, because अगर इस टैंक को आप देखें, so this is the constant, because in the whole tank the area of the water will be constant, which is not variable. But this is not necessary for all of the draining tank. This area will be constant. No, in some time this area must be changed, okay. I will show you in next question. Are in a cone case, if we take a cone, so in cone case the area is not constant and the area will be variable. Then it's constant of water, so if you wanna, then dv by dt is equal to aw dh by dt. यानी आप इस इक्वेशन का विद रिस्पेक्ट टू टाइम जो है ना वो डेरिवेटिव फाइंड आउट कर ले. So you will get dv by dt is equal to aw dh by dt, because h is a function of t. Why? Because we already discussed that we need to find the height of the water at a time t. So it's mean okay, this is the area of this is the function of t. Subtracting this, substituting this loss expression into equation 1. If we put this loss expression into equation 1, give us the desired differential equation of the height of water at a time like this one, dh by dt. Okay, if we put dw by dt equal to this one, हम अगर ये पुट कर ले तो aw d h d h by dt, और फिर w को इस बार प्रेशर कर ले, so we get like this type of equation. And now this equation shows that this is look at this one, rate of change of height with respect to time, okay. So this show the height of the water with respect to time and differential equation. It is interesting to note that equation true remain valid even when AV is not constant. Okay, जैसा मैंने बताया है कि अगर ए डब्ल्यू कांस्टेंट ना हो तब भी ये वैलिड हो. In this case, we must express the upper surface area of the water as a function of h, that is AW is equal to A of h. Okay. In this case, we must, in what case? If the AW is not constant, if AW is a variable, if the area of the water is a water surface is variable, then we put AW is a function of h, because ये with respect to h जो है ना इसमें वेरिएशन आ रहा है. So this is the differential equation, the mathematical problem, mathematical modeling for such kind of draining tank. Now we have a question, a problem like this one. Okay, in this case, if you look at this case, this is also a draining tank, but in this case AW is not constant. Okay, because after time to time this area is decreasing. In this stage the area is maximum, and in this stage the area is maximum. After that area of water surface is decreasing. So in this case the AW is a function of h. Okay. Now the statement of the problem is the right circular conical tank shown in figure 1. यहाँ पर figure 2 होना चाहिए था, लेकिन okay. In problem this is also figure 1. Loses water out of a circular hole at its bottom. Determine a differential equation for the height of water h at time t, which is for greater time in 0. The radius of the hole is 2 inch, where g is 32 feet per second square, and the frictional constant factor is which is c equal to 0.6. ओके, तो यहाँ पर बात करते हैं इस फ्रैक्शन की, कंसंट्रेशन फैक्टर की. तो फ्रैक्शनल जो है ना यहाँ पर गिवन है, तो फिर हमारा जो ये डिफरेंशियल इक्वेशन होगा ये सिंपल इस तरह नहीं होगा, बल्कि यहाँ पर हम वो c ऐड करेंगे एंड c विल रिप्रेजेंट द वैल्यू ऑफ फ्रैक्शन. ओके, सो लेट बिगिन द कैलकुलेट फॉर द मॉडलिंग फॉर दिस काइंड ऑफ प्रॉब्लम. Okay, the volume of water in the tank out of time t is this is the volume of which is 1 by 3 pi r square h. अच्छा, ये वॉल्यूम किसके हैं? ये कोन के वॉल्यूम है, सही है ना. ये पूरे कोन का जो वॉल्यूम है वो आपको बता रहा है, which is you can find out that the volume of the coin will is equal होता है 1 by 3 pi r square h. Now this is equation 1, where r is the radius of the tank. Okay, r क्या है? radius of the tank है, और it height h, और ये h जो है ना ये height of the tank. From the figure, okay, from the figure, look at this one. From the figure, the radius of the tank is 8 feet and the height of the tank is 20 feet. So put these value, we get okay, no, do not need to put this value. Please find the ratio r by h, which is equal to 8 by 20, और यहाँ से r की वैल्यू फाइंड कर ले. This is basically we find the relation between the radius and the height. So this is the ratio between the radius and the height, which is 8 by 20, और यहाँ से r की वैल्यू फाइंड आउट कर ले. So you will get 8 by 20 h. Put this value in equation number 1. ओके, इस इक्वेशन 1 में पुट कर ले. सो यू वी गेट v इज इक्वल टू 1 बाई 3 पाई, और ये r की वैल्यू है स्क्वायर h. आप 8 ये कैंसिल होते हैं, 4 2 ज़ा 8, 5 4 ज़ा 20, और होल स्क्वायर. सो इफ यू टेक होल स्क्वायर, सो 8 गिव अस 1 बाई 3 पाई 4 बाई 25 h स्क्वायर इंटू h. इन दोनों को मल्टीप्लाई कर ले h क्यूब, और इससे आ जाएगा वॉल्यूम इज इक्वल टू, वॉल्यूम ऑफ द टैंक इज इक्वल टू 4 बाई 75 pi h cube. Okay, in this case v is also the function of t and h is also the function of t. Okay, because volume of अगर हम देखिए, अच्छा, तो अब हम क्या करते हैं, डिफरेंशिएट विद रिस्पेक्ट टू t. वी हैव बोथ साइड अब विद रिस्पेक्ट टू टाइम जो है ना वो इसको डेरिवेटिव ले. सो डेरिवेटिव ऑफ v एंड डेरिवेटिव ऑफ दिस वन. सो यहाँ पर वी टी जो है ना ये फंक्शन ऑफ टी है, तो यहाँ से डी वी बाई डी टी आ जाएगा, और इस केस में एच फंक्शन ऑफ टी है, तो ये दोनों कांस्टेंट है, इसको आप बाहर निकालें 4/75 पाई, और ये से आ जाएगा 3h² and again the derivative of base which is dh by dt. Why? Because h is a function of t. So if we अगर हम इसकी कैलकुलेशन कर ले, so we get dv by dt like 4/25 pi h square dh by dt. And now find the value of dh by dt. So the other term should be transferred to the left side of the equation. So we get dh by dt is equal to 25 by 4 pi h square dv by dt. This is equation number 2. Also the rate of change in volume with fraction at whole is okay. This is the volume of water. So dv by dt, और ये इक्वेशन हमने पढ़ा है पिछले, अभी जो मॉडलिंग कर रहे थे वहाँ पर पढ़ा था, लेकिन सी नहीं था, वॉल्यूम डिक्रीज हो रहा है, तो सी इसलिए माइनस का साइन भी है, सी नहीं था क्योंकि कांस्टेंट फ्रैक्शन उसमें नहीं था, एंड बट इन दिस केस फ्रैक्शन इज प्रेजेंट, सो वी पुट सी ए एच एंड 2g h. Okay, so where c is equal to 0.6 which is given, r is equal to 2 inch, तो 2 इंच है, इसको आप फीट में चेंज कर ले तो 2/12 फीट आ जाएगा, और g की वैल्यू ऑलरेडी गिवन है 32 फीट पर सेकंड स्क्वायर। और इस फिगर में अगर आप देखें, सो वी डोंट नो अबाउट द हाइट ऑफ द वाटर, ओके, जिसको h से डिनोट किया हुआ है। दिस 20 फीट इज द हाइट ऑफ द कॉन बट नॉट द हाइट ऑफ द वाटर, सो h इज सेम here. यस देयर, तो ये वैल्यूज आप पुट कर ले तो अच्छा। नाउ फाइंड द एरिया ऑफ द होल। सो एरिया ऑफ द होल अगर आप फाइंड आउट कर ले, सो विच इज द एरिया ऑफ द सर्कल विच इज पाई आर स्क्वायर, पाई अपनी जगह और आर की जगह 2/12 स्क्वायर फीट स्क्वायर आ जाएगा, तो एरिया आ जाएगा पाई/36 फीट स्क्वायर। नाउ पुटिंग दीज वैल्यू इन द अबव इक्वेशन, सी की जगह 0.6, ए एच की जगह पाई/36 और 2 अपनी जगह पर, और g की जगह 32 और h भी अपनी जगह पर। ओके, इफ वी सिंप्लीफाई दिस कैलकुली, यानी इसको भी आप सिंप्लीफाई कर लें, वी गेट पाई/60, ये 64 आ जाएगा, ये 8, और इसको अगर आप सिंप्लीफाई कर लें, सो वी गेट dv by dt इज इक्वल टू -2 पाई डिवाइड बाय 15 अंडर द रूट h. Now this is a rate of volume of water is equal to this one. Now put this in equation number 2. So equation number 2 हमारे पास ये है, इस equation में dv by dt की जगह आप ये value put कर ले, so we get like this one, dh by dt is equal to 25 by 4 pi h square, और ये आपके पास dv by dt की वैल्यू आ जाएगी which is -2 pi under the root h divided by 15. पाई के साथ कैंसिल होगा, 2 के साथ 2 1 2 2 2 4, 5 5 25, 5 3 15, and we get dh by dt is equal to -5 divided by 6h whole power 3/2. Now this is a differential equation for the height. Okay, now this is the differential equation for the height of the water, height of the water with respect to time. In this case, h is a function of t. Okay, h is a function of t. So you can find the solution of this equation if we have the practical phenomena of this type of tank. Okay, अगर हमारे पास इसका प्रैक्टिकल डेटा हो कि फॉर एग्जांपल ये इतने टाइम में इतना था, तो ये कितने टाइम में जो है ना वो टोटल ख़त्म होगा, तो देन वी यूज़ दैट डेटा टू and use this last equation to to find out the time which the whole tank is empty and so on. Okay, so this is the modeling of that type of fluid, that type of model. So this is enough for today. As usual, if you have any problem, you have any question, you have any suggestion, you can feel free to contact on my WhatsApp group, or for the live session you can call me on my Zoom ID, which is mentioned in the start of the lecture. Okay, best of luck.